So now we'll discuss what are the functions we use to calculate nth moment of a random variable. Okay, so here we have two functions to calculate nth moment of a random variable, that is characteristic function and moment generating function. These are the two functions we use to find out the nth moment of the random variable. Okay, so first we'll discuss what is characteristic equation. Okay, so the characteristic equation is nothing but the expected value of e power j omega x. Okay, e power j omega x is called the expected value of e power j omega x is called the characteristic equation. Okay, so phi, how do we denote it as phi x of omega is equal to expected value of e power j omega x. Okay, now what is omega value? Omega value will be varying from minus infinity to plus infinity. J is the imaginary operator. Okay. So phi x of omega will be integral minus infinity to plus infinity e power j omega x f x of x dx. This is the equation for continuous random variable. Now for discrete random variable, what we'll be having? Instead of this integral, we will be having summation and e power j omega xi, we have to consider each and every element, e power j omega xi. Instead of probability density function, we will be having probability mass function, that is p of xi. Okay, so what is this characteristic equation? See, observe this equation. So if you observe this equation, so finally when you obtain the characteristic equation, okay, the function which is in the form of x now converted to the function which is in the form of omega. So the characteristic equation is transforming a random variable from x into the another variable omega. So x is converted to another variable omega. So this is called Fourier transform of fx of x. Only what is the difference between Fourier transform and characteristic equation? In Fourier transform, we will be having minus sign here now, whereas in the characteristic equation, we have plus sign. That is the difference. Okay, so it gives us the Fourier transform of fx of x such that the sign of omega should be reversed. Okay, so fx of x with the sign of omega reversed. For Fourier transform, we will be having minus sign, whereas for the characteristic equation, we will be having the plus sign. Okay. So similarly, the inverse Fourier transform of phi x of omega gives the probability density function with the sign of x is reversed. Okay. So what is inverse Fourier transform? It is f x of x is equal to 1 by 2 pi integral minus infinity to plus infinity phi x of omega e power j omega x dx. Okay. So if you compare this equation with the inverse Fourier transform, what is the difference we have? In the inverse Fourier transform, we will be having the plus here, whereas in the characteristic equation, we will be having minus. Okay. So this gives us the inverse Fourier transform of inverse Fourier transform of phi x of omega such that the sign of x is reversed. So here instead of plus we will be having minus here, no, that is why sign of x should be reversed. Okay, so what is that we can say? Phi x of omega and fx of omega form Fourier transform pairs, but the signs of variables are reversed. Okay, so whereas in the Fourier transform, wherever you have minus, here we'll be having plus. Okay, that is why. So this will give us Fourier transform pair with the sign of variables reversed. Okay, now we'll discuss this theorem here. If phi x of omega is the characteristic function of a random variable x, then the nth moment of x is given by mn is equal to minus j power n d power n phi x of omega by d omega power n, where omega is equal to 0. Okay, so this is the theorem. We have to prove this theorem. Okay, so to prove this theorem, what is that? We know that the characteristic equation is what? It is the expected value of e power j omega x. Characteristic equation is expected value of e power j omega x. Now we will be writing series expansion for e power j omega x. If you write series expansion for e power j omega x, it can be written as 1 plus j omega x plus j omega square by 2 factorial plus j omega x cube by 3 factorial plus so on like this. This is very important. You should remember this equation. Okay. Then e power j omega x can be written as 1 plus j omega x minus omega square x square by 2 factorial minus j omega cube x cube by 3 factorial plus so on. Okay. Now what is characteristic equation now? The characteristic equation is nothing but the expected value of e power j omega x. So in the place of e power j omega x, we will be substituting this term. Okay, it is expected value of 1 plus j omega x minus omega square x square by 2 factorial minus j omega cube x cube by 3 factorial plus so on. Okay. Now we apply this expected value to each and every term. Expected value of 1 will be what? Expected value of 1 will be 1 only plus j omega. Expected value of x is expected value of x, here we are writing omega square by 2 is constant, we write it outside. Expected value we are applying to only x square. Okay. Similarly here also minus j omega 3 by t 3 factorial is constant. We are writing it outside. Expected value will be applied to only x cube. Okay, so on. Now we know that what is zeroth moment? Zeroth moment is having value 1. No? So m naught is having value 1. M1. What is M1? What M1 is nothing but the expected value of x. What is M2? M2 is nothing but expected value of x square. M3 is expected value of x cube. So on. Okay. Now, so now we substitute omega is equal to 0 in this equation. Students, substitute omega is equal to 0 in this equation. So what you get? Only we get m naught. Yes or no? We get only m naught. So phi x of 0 will be equal to m naught, that is equal to 1. Now we differentiate phi x of omega with respect to omega. If you differentiate, what happens to m naught? M naught will be 0. Now j omega m1 we have not differentiated with respect to omega. So we will be having j m1. We will be having j m1 minus, here we are differentiating with respect to omega. So we get 2 omega, 2 will get cancelled. So we get omega m2, okay, minus j 3 omega squared by 3 factorial. So it is minus j 3 omega squared by 3 factorial m3 plus so on like this. Okay. Now substitute omega is equal to 0. If you substitute omega is equal to 0, we will be having jm1 here. We will be having jm1. Similarly, differentiate what is m1 now. Send this j to the other side now. Send this j to the other side. So we'll be having minus j d phi x of omega by d omega. Substitute omega is equal to 0. Now second time if you differentiate with respect to omega, if you differentiate with respect to omega, what is the term we get here? Second time we are differentiating with respect to omega. So this term will become 0. We have minus m2 minus j, okay, minus j omega m3. We'll be having this term, yes or no? Minus j omega m3. Now substitute omega is equal to 0. If you substitute omega is equal to 0, we get minus m2. What is minus? J square, no? Minus is nothing but j square m2. Now what is m2? M2 will be minus j square d square phi x of omega by d omega square, where omega is equal to 0. Okay. Similarly, this can be expanded for the generalized equation. The generalized equation can be written as mn is equal to minus j power n d power n phi x of omega by d omega power n, where omega is equal to 0. Okay, so this gives us what is the relation between movement. We are finding what is the movement about the horizon from the characteristic equation. Okay, so using this equation, we can find out nth moment about the of a random variable about the horizon can be obtained from the characteristic equation. Okay. Now we'll see the properties of characteristic equation. The first property says that the characteristic function is unity at omega is equal to 0. That is phi x of omega, where omega is equal to 0 is phi x of 0, that is equal to 1. Okay. The maximum amplitude of the characteristic function is unity at omega is equal to 0. So it is having the maximum value only at omega is equal to 0. So all other values of characteristic equation will be less than or equal to 1 only. Mod phi x of omega value will be always less than or equal to 1 only. Okay. And the third property says that phi x of omega is continuous function of omega in the range minus infinity less than omega less than infinity. Okay. And the fourth property says that phi x of minus omega and phi x of omega are conjugate functions. That is phi x of minus omega is equal to phi x star of omega. Similarly, phi x of x star of minus omega will be equal to phi x of omega. This is the fourth property of characteristic equation. And the fifth property says that, so phi x of omega is the characteristic equation of the random variable x. Then if y is equal to ax plus b, then what is the characteristic equation of y? Phi y of omega can be written as e power j omega b phi x of a omega. Okay, so that is the characteristic equation of y. Okay, and the sixth property says that phi x of omega is the characteristic equation of random variable x. Then phi x of c omega can also be written as phi c x of omega. Okay, phi x of c omega can also be written as phi c x of omega, where c is what? Constant. Okay. Then if x1 and x2 are two independent random variables, phi x1 plus x2 of omega will be equal to phi x1 of omega into phi x2 of omega. Okay, this is the seventh property of characteristic equation. Okay, so these are the properties of the characteristic equation. Now we'll see the one problem here. Okay, find the characteristic equation of uniform distributed random variable x in the range 0 comma 1. Hence find m1, the first central moment. Okay, so what is that given? Uniform distributed random variable. What is the density function? Fx of x is equal to 1 by b minus a, where x value will be ranging between a and b, 0 otherwise. Okay, so what is the range? It is given as a 0 comma 1. In the question, the range is given as 0 comma 1. So what is that? A is 0 and b is 1. So what is fx of x? 1 by 1 minus 0. So it is 1 in the range 0 less than or equal to x less than or equal to 1, 0 otherwise. Okay. Then what is the characteristic equation? Phi x of omega. So here fx of x is having value 1 in the range 0 comma 1. No? So it is integral 0 comma 1 e power j omega x dx. Okay. So integrate it and substitute the limits. So we got phi x of omega is equal to 1 by j omega e power j omega minus 1. Okay. So this is the characteristic equation. Now we have to find out the first moment about the origin m1. What is the formula to find out m1? m1 is equal to minus j d phi x of omega by d omega, where omega is equal to 0. Okay. So find out d phi x of omega by d omega. D phi x of omega just now we found no more. What is the value? E power j omega minus 1 by j omega. Differentiate this with respect to omega. If you differentiate and finally substitute omega is equal to 0, so then we get m1 is equal to 1 by 2. Okay. So this is the uh, first moment about the origin.